Today we're going to look at how to simplify exponent problems that have two exponents. Okay, for example, if I have 4x to the third and the net term raised to the fifth power. Okay, but let's start off with a review. If you flip to the blank side of your notes, let's review multiplying and dividing. Okay, so the first problem is multiplying. Okay, if you're multiplying terms, you're going to multiply the coefficients. 2 times 3 is 6. And then if you have like bases, okay, those have the same base, they're both x's. When I multiply them, I'm going to add the exponents. Okay, so 8 plus 4 is 12. Okay, so you multiply the coefficients, but you add the exponents. Okay, when you're dividing in the second example, okay, you're going to simplify the coefficients again. So 10 over 4. If I try to do 10 divided by 4, it's a decimal, so I'm just going to reduce it. 2 goes into both of those. 2 goes into 4 2 times, and 2 goes into 10 5 times. Okay, so my numbers are going to be 5 over 2. Now if I have like bases, again here I have x to the fifth and x to the first. I'm going to subtract my exponents, but I have to decide if it goes in the numerator or denominator. So there are more x's in the numerator. So 5 minus 1 is 4. The x's are going to stay in the numerator. Okay, compared to the last example here, x to the 9th divided by x to the 11th. Okay, they have like bases. When I subtract them, I'm going to have x squared left over, but this time it's going to be left in the denominator. And I have to put a 1 on top. I can't leave that numerator blank. Okay, so I subtracted the exponents, but there are more x's on the bottom this time, so I left my x in my denominator. Okay, so let's go through a couple more multiplying and dividing. Okay, so 4x to the third times 2x to the third. I multiply the numbers, the coefficients. 4 times 2 is 8. And for my like bases, I add the exponents. 3 plus 3 is 6. X to the fifth times x to the third. They have like bases, so I can add those exponents. And one more multiplying problem. 2 times 2 is 4. X to the third times x squared is x to the fifth. Okay, remember where that comes from. If I expand it, and I look at all my like bases, I'll have x multiplied by itself 5 times. That's where x to the fifth comes from. Okay, let's look at 3 division problems. So 6 to the fifth divided by 6 to the third. They have like bases. I'm going to subtract my exponents. 5 minus 3 is 2, so I have 6 squared, and I'm going to leave it in the numerator because there are more 6's in the numerator. Now I can put a 1 down here, but dividing by 1 does not change the problem, so I do not need the 1 when it's in the denominator. X to the fourth divided by x to the seventh. Okay, like bases, I subtract my exponents, but I have more x's in the denominator, so I'm going to have x to the third left in the denominator. Now this time I do need a 1. 1 over x to the third. Okay, one more division problem. Okay, for my x terms, x to the fifth divided by x to the first, x to the fourth in the numerator, and y to the sixth divided by y squared. 6 minus 2 is also 4, and I have more y's in the numerator. You don't have to put it over 1. Dividing by 1 does not change the problem. Okay, and one more problem for the back of your paper. Okay, this is an introduction to what we're doing today. Okay, so you have 2 exponents. Okay, what this problem means, it means I have 3x to the fourth multiplied by itself. Okay, I'm doing it 2 times because of my exponent. So whatever I have in that parentheses, I'm multiplying by itself 2 times. Okay, so I would multiply 3 times 3 is 9. And x to the 4th times x to the 4th would be x to the 8th. I would add those exponents just like we did. Okay, but the goal is to go from the problem directly to the answer without this middle step, without rewriting it. Okay, so here's what you do. You're going to do 3 squared. That's where the 9 came from. And when I have these 2 exponents, x to the 4th squared, I'm going to multiply those exponents. All right. I look at this little piece of parentheses here, and that reminds me, parentheses usually means to multiply. I'm going to multiply 4 times 2. And that's where x to the 8th comes from. Okay, so when you have 2 exponents, if there is a coefficient, you're going to raise that to the 2nd power. And then where the other 2 exponents, you're going to multiply your exponents. Okay, so let's look at some of these problems on the other side together. Okay, so I have this term raised to the 3rd power. So I'm going to do 5 to the 3rd power. I'll write that out for now. I'm going to do z to the 4th to the 3rd power. Okay, so I have 2 exponents. I'm going to multiply those. 4 times 3 is 12. So I have z to the 12th. And k, 2 times 3 is 6. K to the 6th. Okay, now the 5 to the 3rd. Okay, we can put that in the calculator. We can do 5 times 5 times 5. Or we can do 5. And then on the left of your calculator, there should be a caret button. 5 caret 3. It looks like this. 5 caret 3. And I get 125. Okay, so if it's a number, we can do the exponent to that number to simplify it a little bit more. I have this whole term raised to the 2nd power. Okay, so everything in that parentheses needs to be raised to the 2nd power. So 5 is going to be raised to the 2nd power. B to the 4th to the 2nd power. I'm going to multiply those exponents. So 4 times 2 is 8. And w is to the 1st. So 1 times 2 is 2. Okay, again, I can do 5 squared. 5 squared is 25. Bring everything else down. Okay, you can call this power of a power, or if you have 2 exponents. So I'm going to do 8 to the 3rd. B, 5 times 3 is 15, so b to the 15th. Okay, and don't forget, when there's a variable by itself, you can put a 1 as its exponent. So for z, 1 times 3 is 3. And then 8 to the 3rd power is 512. Raising everything in that parentheses to the 3rd power. So the 2 is going to be raised to the 3rd power. The d was to the 1st, but now 1 times 3 is 3, so the d is to the 3rd. And for the w, 6 times 3 is 18. Okay, simplify the number a little bit more. 2 times 2 times 2 is 8. Okay, we're going to do 2 more together. So I have 2k to the 4th. That whole thing is raised to the 2nd power. So the 2 is raised to the 2nd power. And the k to the 4th is raised to the 2nd power. Okay, 4 to the 2nd, k to the 4th to the 2nd. 4 times 2 is 8. Could simplify the coefficient. 2 squared is 4. I'm going to do 3 to the 4th and n to the 6th to the 4th. Okay, so 3 to the 4th, and for the n, 6 times 4 is 24. Okay, 3 caret 4 on your calculator, that tells me is 81 n to the 24th. Okay, and last one that we will do together, 6 to the 4th, k squared to the 4th. Okay, I see those parentheses, that reminds me to multiply. 2 times 4 is 8. And then 6 to the 4th power is 1,296. Again, if you're looking for that on your calculator, it's 6 caret 4. 6 to the 4th. All right, here are some to try. Go ahead, start with number 8. See what you can get. Okay, your answer to 8 is 16g to the 10th y squared. Try number 9. (27n to the 3rd z to the 9th). And one more on this page. Number 10. And the answer for 10 is 6,561 k to the 4th, 8 to the 12th. Okay, we have 4 left. 11, 12, 13, and 14. Try these out, please. Number 11 is 256 b to the 8th, c to the 12th. Number 12, 8s to the 15th, c to the 3rd. Try 13. 6,561 h to the 12th. And the very last one, number 14. And that is 9c squared k to the 8th.